Good morning, everyone. Welcome to the Spring 2020 Climate and Water Update webinar. For those joining us for the first time, welcome. And for anyone who joined us for our webinars before, welcome back. Today, our experts will be giving you an update on temperature, rainfall, and other conditions so far this year, and an in-depth look at the outlook for spring 2020. My name is Jordan, and I'll be your moderator today. I'm joined by Claire, who will be producing today's webinar. Together, we will help make the webinar as interactive as possible. Before we start, may I ask for your attention as we cover off some housekeeping items. With the current situation as it is in Australia, this webinar will be conducted from our respective homes. Please bear this in mind as we may encounter some technical issues during the broadcast. We're all around the country today, including Queensland and here in Victoria. Our broadcast today will run for 60 minutes with plenty of time allocated for questions. This webinar is also being recorded and the video will be shared with you via email. For first-time webinar attendees, please see some helpful tips on your screen now. Most importantly, please note that chat box where you can send through any questions or feedback for the presenters. Please use this and not the Q&A box to send your questions to us during the session. We're going to try and answer as many as possible during the allocated breaks. It is the speech bubble button in the taskbar on your screen. The icon will turn blue once it's on. That's how you know you're talking to us. If you want to test out the chat box now, feel free to tell us your name and where you're dialing in from. In response to feedback received from previous webinars, here is some information on how to participate in our polls. When a poll is in motion, and we're doing one pretty soon, you'll see a set of questions on the right of your webinar screen. Please select your choice, followed by the submit button below them. I'll also take this moment to thank those of you who sent in questions during the registration process. We've developed the content of this session in accordance with the common themes of those questions, so thanks for engaging with us. And finally, I'm delighted to introduce you to our presenters, Robin Jewell and Greg Browning. Robin has a strong interest in finding new ways to interpret and make climate science understandable, usable, and accessible to all Australians. She has worked as a weather forecaster for the Bureau in Darwin and the UK Met Office in England. Greg has worked at the Bureau of Meteorology as a weather forecaster and, more recently, as a climatologist. While he has a broad knowledge of meteorology, his specialization is in tropical weather and climatology, having worked in all three bureaus' tropical locations, including 10 years at Darwin. We have a Darwin reunion today. Welcome, guys. Greg, would you like to tell us what we'll be hearing about today?
Yeah, hi, Jordan. Hi, everyone. So we're going to have a quick look back at what happened in winter. Then the bulk of the presentation will be looking forward, so the spring outlook, and we'll cover such topics as potential bushfire weather for the coming months, heat waves, flooding, drought, and because we have quite an interesting setup as far as potential climate drivers developing in the coming months, we'll have a bit of a look at what's influencing the climate.
Excellent. Plenty of stuff to get into, but before we get into it, let's start off with our poll. The question is, how was your winter rainfall? Was it A, above average, B, average, or C, below average? While you get your answers in, and you'll see them pop up on the right-hand side, we'll get to a few questions. So first, Sam would like to know, what is the weather outlook for spring planned burning in the northern region? I think that's a good one for you, Robin.
Hi, Sam. I actually noticed that you had Tas in your email address, so I'm assuming that you're meaning Northern Tasmania, not Northern Australia. We're going to have a close look at the bushfire outlook later, but for Northern Tas, we're not seeing a push towards it being a particularly bad season. We're just looking at your normal risk for bushfires in spring that you would have in an average year. It does look like it'll be likely to be wetter than average in the northeast of northern Tassie and perhaps drier than average in the northwest.
Okay, excellent. William has asked, what is the cyclone chance or outlook for the top end of Australia, especially the Gulf of Carpentaria, and any increased significant rain events outlook or any significant rain events outlooks for Katherine, Daly, Victoria, and Roper catchments? Mr. Tropics, Greg, I think that's perfect for you to answer that one.
Yeah, thanks for the question, William. So, as I was sort of hinting at, we have a setup with the broad-scale climate that potentially means we may have a more active than usual tropical cyclone season this year. So, as a whole, the Australian region normally sees more tropical cyclones during La Nina and a negative Indian Ocean dipole year than what it would in an average year. It's pretty hard to narrow down locations, but with these climate drivers in play, which at this stage looks a reasonably high possibility, all those areas you talked about are likely to see above average rainfall. And as you're probably aware, with the higher chance of tropical lows and tropical cyclones, that could mean widespread flooding and localised flooding across a lot of the top end and northern Australia in general.
Okay. Excellent answer. Now, it seems that we have a naturalist with us, Erica. She's posed an interesting question. Does the BOM consider that this spring many things are happening early, like flowers and birds nesting? Could that be an indicator of an early hot summer? Greg, why don't you take that one as well?
Yeah, no, that's a very interesting question, Erica. And there certainly are a whole lot of indications that we've seen in recent years that suggest the typical seasons are just changing subtly, earlier springs, perhaps earlier summers and things like that. We don't incorporate that information directly into our climate models and our Outlook products, but because those particular products do incorporate everything that's going on in the atmosphere, it will bring in information such as it being extra warm in a particular area, or there be extra wind or surface pressure in the area. So while there's one level of seeing those actual on the ground changes to the weather system, we're looking at those empirical measurements that we can put into our models, like a higher pressure, higher temperature, higher humidity, etc. So even though we don't explicitly take into account those natural factors, the way our models look at everything that's going on in the atmosphere, it sort of implicitly is in line with what you can see actually on the ground.
Okay. We've got an interesting question from Paul. He's asked that most athletes in WA train early mornings. So what can we expect? Dry versus wet, cold versus warm, windy versus calm. Now, clearly, Paul believes that his team has a chance of making the AFL Grand Final. What do you think about that WA early training session question?
Oh, that's a good question. For Southwest Western Australia, it is looking like it might be a drier and warmer start to spring. So September may be drier and warmer than average. But then when we look over the rest of spring, we're not seeing a particularly strong indication either way towards it being particularly warm or cool or wet or dry. In terms of winds are a really challenging one to forecast on those longer timescales. So we can do temperature and rainfall, but when it comes to wind, we're really limited to that 7-day weather forecast. So that's where downloading the BOM weather app and keeping an eye on the winds over the next week is probably your best bet there for your morning training sessions.
Excellent. And go Swans. So we've got our questions back. Our questions for the poll. At the moment, most people believed that they had an average rainfall amount this winter. Thank you for participating in the poll. And don't forget, we have a session to get your questions answered by our experts in a little time. So start sending them in the chat box now. You can just put in a question, any question that you want, and we'll try and get to them. Greg, take it away.
Thanks, Jordan. Okay, so as we said, we're going to have a bit of a look and see what the weather conditions were like in winter right across Australia. So the first map we're seeing here is a map of rainfall during the 3 months of June to the end of August. Red indicates drier than average, the blue colours indicate wetter than average, and white is pretty much close to average. So while the perception probably was that it was quite wet winter, really it was confined to much of the New South Wales coast, as far as those really wet conditions were, and pretty much as a result of a couple of intense weather systems. But there was a fair bit of average to above average rain extending right back to Central Australia, southwestern Queensland, etc. Overall, though, you can see how much red there was in the western half of the country and in northern places. Australia was still 31% below its long-term average, and WA in particular had its 8th driest winter on record. So it was a bit of a tale of two halves, really, and some places, if you lived in Sydney or the south coast of New South Wales, you would have thought it was very wet, but you didn't have to go too far west to see that it wasn't quite wet on a really widespread basis. If we look at temperatures, so here we've got maximum temperatures, and the colours here basically are the more orange we see, the higher it was compared to the long-term average, and we don't really have any blue on the map at all, so that shows no strongly below average maximum temperatures. But again, much of New South Wales and parts of Southeast Australia did see near average conditions. So overall, it was very warm across Australia. So if we take the average of the whole country, it was 1.6 degrees above the long-term average. And Western Australia, as you can see, with a lot of orange dominating that state, actually had its highest winter maximum temperature on record. Other parts of Northern Australia were also very warm. So Northern Territory and Queensland both had were both in their top 10 of highest maximum temperatures record. If we go to minimum temperatures, again, there's quite a lot of warm colours, the yellows and the oranges, but we also are seeing a fair bit of blue and a lot of white, so much closer to an overall average picture. Although having said that, Australia was still 0.7 degrees above the long term, but it was dominated by cooler and near average temperatures down in the southeast, extending into South Australia, and Western Australia again had some pretty high nighttime temperatures. So Australia overall, West Australia overall was nearly a full degree above its long-term average. So yeah, it was a bit of a mix. So we saw that extra rain and extra wind over parts of the southeast, keeping the temperatures down. But elsewhere, it was still quite warm, even looking at the overnight temperatures. Okay, so soil moisture. What we're looking at here is how much moisture is in the top 1 metre of soil across the regions that we measure. And this gives an idea of just a build-up of rain. It obviously takes a little bit of time for rainfall to percolate into the ground. And it gives us a sense that, okay, there has been at least some widespread, prolonged sort of rainfall in certain areas. And what's very interesting, we know at this time last year, we were coming out of a very dry winter and heading into potentially disastrous fire weather conditions. So that little map on the left-hand side just shows how dry it was. So again, red's indicating below average soil moisture and the blue indicates above average soil moisture. So with the rains that were reasonable over parts of the east and central Australia, you can see there's a reasonable area of improved soil moisture. Still over lots of the country, the soil moisture is only average and below average in parts as well, but certainly some recovery, particularly compared to this time last year. This is quite interesting. So again, we've had the perception that this year has been relatively wet, and certainly compared to recent years it has been. So the small map on the left there is basically showing the rainfall for the first 8 months of this year. And again, you can see there's not that much red, a bit of blue, particularly over New South Wales, and a lot of average over much of the country. So that certainly has helped the long-term rainfall deficiencies that had built up over the previous few years. So the recent drought started close to the beginning of 2017. So what we've got here is looking at the long scale picture of rainfall deficiency. So those nearly 3 and a bit years of rainfall deficiency. And you can see that even though we had reasonable rains in the first half of this year, hasn't made much of a dint over a lot of those parts of eastern Australia in particular, but also southwest and western Australia and right along the coast there. So you can see it takes a long time to recover those areas that have had extended drought conditions and long-term rainfall deficiencies. So while soil moisture gives us a sense that we've had some good recent rainfall and it's making a change in the landscape, you can see that overall long-term rain deficiencies take a lot more than just a few months of average to above average rainfall. We're going to really need extended periods of above average rainfall to make a big dent in those areas that are seeing long-term rainfall deficiencies. And an example of how long it does take sometimes to recover from those long-term rainfall deficiencies is looking at the water storages. So we're just looking at 4 areas where there's some quite interesting sort of comparisons between locations and how they've fared in recent months and years. So looking at the one up the top right, that's the Northern Murray-Darling Basin. So this time last year, it was really close to record levels. You can see it did actually get into single figures. So there's been some recovery as far as what recent rainfall has done to that broad storage area in recent months, but it's still only at 25%. So well below average, but improvement on what it was last year. However, if we go down to the Sydney Basin, we can see that as a result of those very heavy rainfall, mainly in July and August, we're actually close to 100% full in that storage and a major improvement on what it was this time last year. Heading over west, you can see down in the south, it's below average what it normally is at this year. It normally gets a bit of a recharge in winter. That's WA's or Southwest WA's typical wet time of the year. Of more concern for people living in the north is places like Argyle near Kununurra is very dry. So it's been 3 years since the dams have filled up there, and they normally do after a typical dry season, but with 2 especially bad dry seasons over the last few years, they're well below average, and heading into this wet season, they have some, I think it's the lowest storage level since 1993. So they'd really be hoping for a good wet season over the coming 6 months or so. That's my wrap up of winter, and I think we're over to Robin now to have a look at the spring outlook.
Thanks, Greg, for that excellent wrap up. So now I'm going to start taking us forward in time so we can have a bit of a look at what we can expect in the coming months. And I thought a good place to start would be rainfall. And the map that we're showing here is for all of spring and the chance of Australia exceeding median rainfall. So what this map shows us is that for the eastern 2/3 of mainland Australia, the chance there of exceeding median is actually quite high to very high in some locations. So that darkest colour there indicates a greater than 80% chance that we'll see more rainfall than usual this spring. In contrast, though, in parts of Western Australia and also Western Tasmania there, the outlook is more neutral to even drier than average. But one thing we can do is break this down a little bit, and we can look at what we can expect in the individual months of spring. So we've got September on the left and October on the right there. And what this tells us is that that rainfall signal is very pronounced in October, not so much in September. We do see that wet signal there in central and northwestern Australia, but actually in September, most of the country it's quite white. The outlook is quite neutral. We're not seeing a strong push either way. And in Western Australia, along the coast there, and in Tasmania there, and parts of southern South Australia there, there's actually quite a dry signal. So this is indicating perhaps a dry start to spring in those locations, but in southeast Australia, it's likely to be a wet end to the southern growing season there. Let's take a moment, though, and take a closer look at northern Australia, because it is, next slide, Greg. It is a time of transition in northern Australia from when we go to the dry season into the wet season. And we do a forecast to look at whether those rains that we associate with the wet season are likely to come in on time or earlier or later than usual. The greenness on this map here is indicating this year it's likely that these northern rains will come in earlier than usual. So we use a measure which is relevant to agriculture, which is what this was designed for, this product. So it's when we get our first 50 millimetres of rainfall after the 1st of September, and that's generally considered enough to stimulate plant and pasture growth. So it's an indication that the wet season is underway. It's perhaps an early start to the northern wet season this year. Next slide, Greg. We do know that in our audience, we do get lots of questions about specific locations. So we know that not a broad overview of what's going to happen across the whole country suits everybody's needs listening in. We know a lot of people just want to know what's happening where their business or where their operation is. And so this is a chance just to remind everyone, I put the link down the bottom. We have so much information on our website. We have the ability for you to pan and zoom or search for a location and really drill into the data for where you live and get a lot more detailed information. So not just the chance of it being wetter or drier than usual, but we can give you indications on the likelihood of how much rain you might get. So the example I've selected here is for a 2-week period that straddles the middle of the month, middle of September. And I've chosen a location in southwest Western Australia and the likelihood of receiving exceeding 10 millimetres. So it's about a 50-50 chance in that fortnight that will exceed 10 millimetres, but we can see from the graph in the pop-up box, there's a very high chance in that fortnight that we'll see more than 5 millimetres. We see that 15 and 25 millimetres are possible, but unlikely. We see that our model predicts 0 chance of seeing 50 millimetres in that fortnight. So there's a lot more data there to be investigated for your location. So it's just a reminder there. But let's now take a look at streamflow. So Greg talked about soil moisture, and we saw that we do have a lot of replenished moisture in parts of eastern Australia where we've seen a lot of rainfall this year. So along the coast there and in Victoria, and in those locations, high flows are likely in the coming 3 months, the August to October period. But actually, at most forecast locations, we forecast streamflow for, so over 80% of the locations that we forecast for, we're actually looking at medium to low flows, particularly in southwest Western Australia there. That's where we see those low flows since we haven't had a lot of wetting up of the soils there. Now let's do the temperature. So if we turn to temperature, we do have a lot of warmer ocean around Australia, which Greg will talk about a little bit more in what that means for our outlook. But one thing it does mean is we're more likely to see warmer temperatures both days and nights there. So all those dark red colours are a really high chance that we'll see temperatures being greater than median. So for night times there, apart from southwest Western Australia, that chance is quite high. In southeast Australia, that could mean that we maybe don't see as many severe frost days as we do in other years. Still possible, but perhaps less likely than in other years. In terms of days, where we expect to see more cloud and rain, that may reduce daytime temperatures because we'll see less spring sunshine there. Next slide, Greg. So now I thought let's have a look at what our rainfall and temperature forecasts mean for some of our more hazardous weather as we go into our severe weather season, and bushfires is probably a good place to start. Our AFAC and the Bushfire Natural Hazard CRC released the bushfire outlook for spring earlier this week, and the Bureau works in partnership with these organisations to provide the weather data that goes into these outlooks. And while weather data is a really important ingredient, there is a lot of other information that go into these outlooks, such as information about the state, the amount and how dry fuel is, and prescribed burns that have been done so far this year. What this map shows, though, is that for most of Australia, the bushfire potential is near normal, what it would be in an average year. The areas where we see an elevated risk are along the Queensland coast there, and also in parts of the Kimberley. There's a few extra high risk areas where we need to keep a closer eye on. But even in average years in bushfire prone areas, there's always a risk of bushfires. And this is the transition season. So we're seeing the continuation of the northern bushfire season, but we also see the commencement of the southern Australia bushfire season. I know some people are keen to even look further than just spring to know what's going to happen in summer as well with bushfires. And we do know that with a wetter than usual outlook during spring, which is what we have in Eastern Australia, while when we're having that rain and it's damp and it's humid, that reduces bushfire risk. In springtime, wet springs have their own associated risks with them for bushfires, and that's in increasing the amount of growth that we may have during the spring season. And naturally, that dries off in Australia in summer in the south. So one thing that is on the top of people's minds for this summer is an increased risk of fast-running savanna fires, grassland or cropping area fires. It is a bit of a watch and a wait and see what happens in spring, but that's what the thinking is of an area of concern for the south as we move into summer as well. Next slide, Greg. So we use our rainfall, temperature and stream flow outlooks to make assessments on all sorts of likelihood of severe weather during spring and summer. So I've spoken about bushfires. Heat waves is another risk that starts to appear in spring. It's increasingly been likely for us in Australia to see spring heat waves with global warming and that background warming of the climate and an increase in the likelihood of extreme heat days. But we will talk a little bit later about La Nina. Now, La Nina can act to reduce the average daytime maximum temperature that we see across Australia in spring and summer. But it's quite nuanced with La Nina. In La Nina, we can also see an increased chance in longer lasting, weaker heat waves. So we might not see those really hot extreme days, but we might see slightly less extreme heat last for longer and be more humid. So there's quite a bit of nuance. It's hard to capture in one table here. So for heat waves, that's where we're standing for spring and summer. With the increased risk of more rainfall, that quite obviously increases the risk of widespread flooding, especially in those areas where the soils are already saturated. With severe storms, so those are storms where we can expect large hail, destructive winds and flash flooding, there is actually a very weak relationship between a slightly increased amount of severe storms occurring west of the Divide and in Victoria during La Nina, but it's very weak. Overall, across Australia, we're not seeing a strong indication either way towards whether we'll see more of these storms or not this year. Drought is one of the better stories for an outlook the way that we have like this. So in the east, in particular, improvement is likely. I know in southwest Western Australia and southern South Australia, though, it has been very dry there. And we may see a dry start in southwest Western Australia to spring, but the outlook's quite neutral for the rest of spring, so it could go either way. With dust, that's quite related to soil moisture. So where the soils are dry, we can see lifted dust. So we actually saw some dust in South Australia, some dust storms occurring this week. So that will be again where the soils are dry, it'll be a risk, but with a wet outlook in the east, it will be less of a risk this year. And I'm not sure if coral bleaching is of interest to the audience. Coral bleaching is something that's occurred more frequently in recent years with a warming climate, but this year we're not seeing a strong indication towards it being a particularly bad year for coral bleaching, but we do have a long way to go, so we still need to watch that space. We did already earlier talk about tropical cyclones. So with La Nina and a wetter than usual outlook and an earlier start to the wet season likely, we also do see it more likely that we may see more tropical cyclones than usual forming in our waters as well. And coastal inundation is another one that's going to be a watch point with increased chance of rain and flooding, wet soils, and also higher sea levels now. We see an increased risk of coastal inundation events, and we actually saw a significant event already a couple of weeks ago in New South Wales. So that's pretty much a wrap of how our rainfall and temperature and streamflow outlook may impact on severe weather, not just for spring, but in summer as well. Before we stop, I think it's a good time to stop soon for Q&A, but just before we do, I did just want to change tack a bit and just talk about the accuracy of our model. Next slide, Greg. This is a really common question that comes up. We often get questions submitted and are asked questions, so I think it's always a good idea to talk about it. So we get asked how accurate our model is quite often, and it's a really fair and good question. We take model accuracy really seriously at the Bureau. Our current outlooks are produced from a model we call Access-S, which came into service in 2018. And before we brought Access-S into service, we did really rigorous testing of its performance. And it's actually kind of neat the way we do that with computer models. We trick our model. We tell our model that it's August 1990. We put in all the observations of the atmosphere and the ocean that we took in August 1990, and we run the model and we have it forecast for spring in 1990, and then we compare what it forecast against what actually happened. And we did that over and over again for over 20 years for every forecast period that we forecast for, and we've summarised the results here. So we always encourage, we've got the links there, that you do check the past accuracy of the model before using a Bureau Climate Outlook. Anywhere where the past accuracy maps are green, that means the model has performed well in the past. It performed better than using your average climate as a guide. But anywhere where we see white, we would actually advise you use our model outlooks with a lot of caution in those areas. We've got a lot of green on our maps at this time of the year, which is really good. It's a time of the year where the model performs well. It isn't just a tick the box, I've checked it once, I don't need to check it again. It's something you need to do every time because the skill of model changes with the time of the year and location. So by all means, click on the links and have a really good investigation if that's something that is of interest to you. But I think now I've talked a lot, so let's have some time for questions.
Yeah, thank you, Robin. That gives us a great understanding on what's happened in the last few months and for the months ahead. And those links that are clickable, you will be able to click them when we send out the email later today. There's the full presentation material for you to go through. So we're going to deep dive into the influences on climate in a minute, but let's go to our second poll. We'd like to know, why do you think this spring is likely to be wetter than average in the east? Is it A, El Nino, B, La Nina, C, a negative Indian Ocean dipole, D, La Nina and a negative IOD, a southern annular mode for E, or F, other? While you guys get those in, we're going to get to some more questions. So this one comes from Ing. They'd like to know that they're interested in general patterns and combination of drivers which determine relationships between rainfall for southwest Western Australia and New South Wales and Victoria. Also interested in long-term outlook for rainfall in southwest Western Australia. Greg, I believe you're the perfect person to answer that one.
Yeah, sure. So as Robin hinted at before, ENSO and La Nina and those climate maps showed it very starkly, how the influence, certainly with rainfall, is more pronounced in the eastern two-thirds, and Western Australia normally doesn't see as much an influence from these broad-scale climate drivers like La Nina, as well as a negative Indian Ocean dipole. As you go further south in the country, those climate drivers do dominate, but then we also have other climate drivers start to have an influence as well. So the southern annular mode is one in particular that has a big influence on parts of southern Australia. So Western Australia is quite an interesting one. So it really isn't influenced as much with these big scale climate drivers that we see like La Nina and negative IOD. However, things like the southern annular mode and of recent times, we've really seen climate change having a big impact on the variability of rainfall, as well as other weather parameters there. So West Australia can be quite unpredictable compared to parts in Eastern Australia because we don't have the guidance that these really big, strong climate drivers can offer us in years such as this. So yeah, hence Western Australia being unpredictable, and they've had a drying trend there that's gone on for a long time, and sometimes it's very hard to pick when they are likely to see periods of extended above average rainfall.
Okay, thank you, Greg. Kirsten has asked, what does this all mean for ocean currents across southern ocean temperatures and currents, across southern Australia? Robin, you started talking a little bit about coral bleaching before, so I think you're the perfect person to answer this one.
Thanks, Jordan. Well, we do have there is a known relationship between the Lewin current and La Nina. I feel like we're definitely giving away the answer to the poll here, by the way. The Lewin current runs down the west coast of Australia and around the bottom and along southern Australia there. So during La Nina, we often see warmer water than usual in the Western Pacific, and that warmer water can feeds through the Indonesian through flow and can make that current stronger, bringing warmer water, travelling that warmer water down that coast and warming the ocean all the way down that coast and around the tip past Albany as well. So we can see an increase in that current bringing warmer water down the coast. So we actually have the Ningaloo Reef. Sorry, Siri just went off on me, sorry. We actually have the Ningaloo Reef that can be affected by this, that increase in warm water coming across the Ningaloo Reef. So La Nina can increase the likelihood of coral bleaching events for the Ningaloo Reef, actually.
Okay, sticking with oceans, and since the cat is out of the bag, Joshua would like to know, how does La Nina affect ocean temperatures and coral in the Great Barrier Reef?
Yeah, so there's a really strong relationship between El Nino and La Nina and coral bleaching events. Actually, the strongest indicator of when we will get severe events is actually El Nino, and at the end of El Nino. So El Nino tends to reduce the amount of cloud that we see over Australia, and towards the end of El Nino, if you have many, many, many clear days over the Coral Sea, that means we've got a lot more sunshine hours, and that ocean can just heat and heat and heat. So towards the end of El Ninos, because of clear skies, we can see an increased chance of coral bleaching events. With La Nina, you tend to have maybe warmer oceans, but more cloud. So La Nina often reduces the risk. Often it's a difficult one because one is current related and one is cloud related. So it can increase the risk for the Ningaloo Reef, but for the Great Barrier Reef, it doesn't always increase the risk significantly because of the cloud.
Okay. Colin, he's asked, what is the possible La Nina pattern likely to produce in the next year? So, Greg, I'll hand that over to you.
Yeah, thanks, Colin. So La Nina is one of our seasonal climate drivers. So we have shorter term climate drivers, as we talked about with the southern annular mode, that may be an influence for a week or more. But then things like the La Nina and the Indian Ocean dipole, they're often seasonal, so lasting for 3, 6, even longer, 9 months or so. So the normal situation with La Nina is it builds up during autumn and winter, typically reaches its peak strength during early or middle of spring, and then it starts to weaken during summer. Particularly strong events can still have an influence even beyond summer, but most of the time the normal cycle of things means that they will break down either late summer or into autumn. So as with those outlooks that we saw earlier in the rainfall, and it gave us a good idea of the evolution of the current La Nina, and it's a little bit slower than usual. So whereas we would normally see some reasonably pronounced influences of La Nina in September, we could see by that rainfall map that really it looks like it's more so October when La Nina is really going to have close to its typical influence and widespread rainfall. So at this stage, we're expecting the La Nina that we're looking at the moment to become mature over the next month or two, and potentially then being an influence into summer and perhaps beyond. At this stage, the event or the model of the event, the models that we look at don't suggest it's going to be as strong as, say, the really strong La Nina we had in 2010 or 2011. So it's probably going to be more likely a moderate strength El Nino, in which case it's probably likely to start breaking down during summer, and the influence will start waning as we get into certainly that second half of summer.
Okay, excellent answer there. Our poll question is complete, and most people, yes, they think they caught on. They said it was D, La Nina, and a negative IOD. Is that correct, Robin?
Well, I feel like I'm giving it away even more with this talk.
Well, then let's keep it quiet and let Greg
Yes.
do his thing. You've got another chance for a Q&A session coming up in just a little bit, and we'll get to more of your questions then, so please send them through in the chat. But right now, Greg is going to talk a little bit more about those climate influences.
Okay, so we'll go through the two seasonal climate drivers that we've talked about a fair bit, starting with La Nina. So La Nina is like the opposite of El Nino. So they're all parts of a broader system called the El Nino Southern Oscillation. There's three different phases. It can be either La Nina, it can be El Nino, or it can be neutral, where neither of those are happening and we have what are considered normal patterns of ocean temperatures. But what we see in La Nina, the initial sort of signs of a developing La Nina is we see a change in the trade winds, which is the winds that blow across the equatorial Pacific Ocean, and a buildup of cool water over the central and eastern Pacific. At the same time, the warm water is pushed towards the area around Australia's north. So we see warm waters developing right off northern Australia and extending a lot through those islands and the ocean groups to our north. So that's the early stage of La Nina. We really consider it to be a mature event, and it has its most significant influences when it actually changes the atmospheric circulation pattern that overlies it. So you can see those arrows in that schematic there. Basically, they have a pattern where there's upward motion with those the airflow over Australia, and that leads to cloud development and a greater likelihood of above average rainfall, and hence why during La Nina we're favoured to see above average rainfall over much of the Australian region. So that's the current situation at the moment. If we have a look at what's going on in the actual Pacific Ocean, so this is a map of sea surface temperatures taken over the last month. As is the normal sort of convention, red means hot, blue means cold, and we look in particular at that box in the middle of the Pacific Ocean. So we do, or we focus our measurements on what the sea surface temperature is over that box. And you can see there's quite a lot of blue in there at the moment, and that's given us a hint that something is developing over the Pacific Ocean, and it looks La Nina-like. So that's what's been going on. We look at other indications as well. So as I said, it also has a component going on in the atmosphere. So we look at a whole bunch of different measurements going on in the oceans and in the atmosphere. And then that gives us a sense of whether we're looking at a developing La Nina, a mature La Nina, or something else. We're at the stage now where we're calling it, ENSO alert status is at alert, so La Nina alert. So we're between inactive when neither are happening, and we're still one step away from actually calling it a proper mature La Nina event. But when we do see the indicators and the models suggesting that it's a good chance of happening and it goes to La Nina alert, it actually suggests we have a 70% chance of La Nina developing in that year. So we're likely, there's a much better chance than average that we're likely to see La Nina developing. And you can see on the right-hand side, we've talked about this briefly, but it has a distinct influence on the climate. So things like more tropical cyclones, more rainfall, particularly over eastern Australia. As Robin hinted at, while we don't see those really strong daytime temperatures, we can see extended heat waves, and we can see more humidity associated with them as well. So the latest data we have gives us a bit more encouragement and confidence that La Nina is likely to develop. So one thing that's happened just recently, which is quite a key indicator of La Nina, is seeing this red line pop into the blue. So this is the Southern Oscillation Index, and this gives us an idea of what's going on in the atmosphere. And we really want to see those numbers in that blue zone of La Nina to say that, okay, the atmosphere is really responding to the sea surface temperature patterns, and we were starting to see that circulation. And when that happens, that's when we're likely to see those influences in the weather with the above average rainfall, etc. And on the right-hand side, we've just got a whole bunch of international models. And you can see for the most part, they're all pointing more to the La Nina direction on the left-hand side with that blue. So they're looking at forecasting how cold the waters are going to be over the Pacific, and for the most part over spring it's getting closer and closer, if not exceeding those El Nino thresholds. La Nina, sorry, I should have said. Okay, so that was La Nina. If we go over to the Indian Ocean, it's a similar sort of concept, if you like. We can also almost think of the Indian Ocean dipole as the analogue of the ENSO circulation, but obviously in a totally different ocean basin. So again, with a negative IOD, we have changes in the normal patterns of water temperatures across the equator in that ocean basin. And a negative IOD is associated with warmer waters, again, around northern Australia, cooler waters further away. And again, if it's a mature, well-developed system, we will see the atmosphere respond, which means that where those warmer waters are, we're likely to see further upward motion. That means cloud and in turn rainfall. And again, looking at the actual maps of the indications and the measurements that we've made, we can see that there's more red in this eastern node closer to Australia and less in this western area away from Australia. And again, it's showing us that, yes, the indicators at the ocean as well as at the atmosphere start giving us a good hint that negative IOD is a relatively high chance of developing. And if it does, then we're likely to see those sort of impacts that we've already talked about. So things like more rain over parts of Australia. We often see warmer nights in the north because the ocean temperatures around Australia, particularly to that northwest, are warmer than usual. That has an influence on the terrestrial temperatures as well. And with the above average rainfall, we often see increased chance of flooding with a negative Indian Ocean dipole. And we also measure that as we measure everything we possibly can at the Bureau, looking at those temperatures across the ocean. Again, we want to see it go into this blue zone. So we have a particular threshold that we look at. When it exceeds that threshold, it gives us a good hint that something is brewing. And using that in conjunction with what a whole bunch of international models are saying, which is on the right-hand side, gives us confidence that a negative IOD is potentially going to develop over the next month or two. So that is why at the moment we expect there's a relatively high chance of both of those seasonal climate drivers, La Nina and a negative IOD, may be a factor in the coming months, and it gives us more faith in the likelihood of above average rainfall, particularly over those eastern 2/3 of Australia. Thanks, Jordan.
Fantastic. Thank you for that, Greg. I hope that gives you a lot of information on the changes for the months ahead and what's driving them. Now we have a great opportunity for you to ask some questions to our experts, so please start sending them in. We'll get to as many as we can, but we will try and finish on time today at 12 o'clock. We just got a great question from Jasper. He's asked, what is driving expected below normal rainfall in Tasmania when the IOD should support rainfall?
Oh, that's very astute question, actually.
Yeah.
So there is an association with La Nina also driving an increase in the southern annular mode, which we didn't talk about today because we have to pick and choose what we can fit into our hour. With an increase in the southern annular mode, so a positive SAM, we actually see in our latest outlook that it is moving towards the positive side of things. That means that those rain-bearing westerlies may move to a position such that it becomes more likely that we'll see wetter conditions, so it can reinforce that effect over parts of southeast Australia, except in Western Tasmania there. It can reduce the chance of rainfall there, and that's what I think our model has picked up on. So our model, we should say that our computer model, it implicitly includes all of these influences, La Nina, El Nino, the IOD, the southern annular mood, and more. It models everything, the entire atmosphere. So it will look at how will these interact and which are going to be dominant. So I think that's perhaps why the model is doing that for Western Tasmania there. When we look at average, what's happened on average in La Nina years, it actually does pick out a split between the west of Tasmania and the northeast of Tasmania there, with that rainfall influence only in the northeast there, and it being closer to average in the west, or not so influential there.
Okay. Vicky has asked, how do we find out what the median rainfall is for our area? We can see that it is above average rainfall, but how do we know how much is average?
So if you follow many of the links that we've put through the presentation, it'll take you to our Climate Outlooks part of the website. We collect for you, so you can easily click between your median rainfall, your rainfall outlook, and also your past accuracy across any period. So we try and loop them all together so that they're easy for you to, because often you need to look at all three to be able to interpret an outlook.
Of course. Matthew has asked, he just wants a little bit of confirmation on the interpretation of the October rainfall outlook. Dark blue does not mean more rain than light blue or white, or dark blue is relative to a long run average. So he just wants to know a little bit more about how to interpret it.
It's that what we're showing is the likelihood you'll see more rainfall than normal. So it's not how much. So the darker the colour is, the higher the chance. So it's even more likely where the colours are dark, and where the colours are light, the chance is a slight chance. So it might be the difference between only a 60% chance it'll be wetter than average, or an 80% chance that it'll be wetter than average.
Sure. Gareth has said, I manage energy risk across 6 sites in southeastern Australia. Temperature extremes drive consumption in space heating by gas and cooling from a HVAC. What is your outlook for climate extremes in the next quarter, please?
I think we touched on that a little bit with the influence that La Nina has on heat waves. So compared to last year, say, as an example, where we had climate drivers that were really conducive to very intense, single day and multi-day temperatures, in a La Nina, that situation is less likely. However, we can often see those extended heat waves with not the, the absolute record-breaking temperatures, but, close to well above average temperatures extending for a while. The other really complicating factor, and this can certainly be an issue as far as human health goes, is that we often see more humid heat waves over southeastern Australia associated with La Nina. So that again puts another drain on things like air conditioning and what have you, because that really does stress human people when you have that extra humidity during hot days.
Okay. Robert has asked, what's the chance of an East Coast low off the New South Wales or Sydney or Illawarra coasts?
With the East Coast lows, there's not a strong I don't think there is, as far as I know, a strong correlation between La Nina and East Coast lows in particular. But we do know with La Ninas that we do see an increased chance of widespread flooding events, not necessarily from East Coast lows. They might be from slow-moving extratropical cyclones or lows that don't quite reach East Coast low strength, so they're not classified as East Coast lows, or stronger frontal systems. So we do see that increased chance of slow-moving weather systems, which is often why you get the widespread flooding, is because the system moves really slowly, so it gets more rain onto the land instead of whipping past quickly, and half of that rain going over the ocean instead in Eastern Australia.
It's interesting. So Chris has asked a question. It might not have an easy answer, but I thought it was pretty interesting, and I feel this way as well. He said that he lives in southwest New South Wales, and he feels like the wind speeds are increasing. And where I live in Melbourne, I feel like the wind screens, it's doing that as well. Are there, and you did mention about this before, Robin, how wind is hard to predict. Are there any figures comparing this year's winds speeds to former years? Can somebody look that up? Can they find that kind of information?
We could probably, in terms of what's happened in the last few months, we probably have to take that one on notice to take a bit of a more detailed look at your location. And we can actually take questions on notice. We'll have an email address at the end where you can submit your question with your location. In terms of the outlook, we don't forecast wind because it's difficult to do after that sort of 7-day period. With La Nina, there's a relationship between having weaker sea breezes, but that's not going to influence you where you are. And also there is part of the reason why we have those slower moving systems is because there's an association between less wind, strong wind steering those systems quickly. So that's probably not the answer you were after. But if you want more detail about what has been happening in recent months, just let us know in your email where you are, and we can get back to you.
I can briefly add something to that as well. We have had much higher pressure over parts of Australia this winter than what we have in the past. So looking at that, there will be certain areas that will have seen above average winds. Again, it's harder to nail down a particular location, but certainly there have been parts of the country that have seen stronger winds just by virtue of having stronger high pressure systems over parts of Australia this winter.
Okay. Well, Chris, you might be right there, and maybe you got a future as a weather watcher because you seem to be able to predict the wind. That's all the time that we have for today. But if you did miss the start, Robin, would you like to summarize what we spoke about today and where people can find more information?
Certainly. Next slide, Greg. So as we've talked about extensively, wetter conditions in Eastern Australia being more likely, and also a drier start perhaps to the season in southwest Western Australia, which isn't visible here. Actually, these maps are slightly out of date, I think, so do check back here. I'll make sure they're updated before we go into the before we send this to you. Warmer days and nights are more likely. It was the temperature map which alerted me to that. It's too much white on that map. Mostly low to medium stream flows likely, except where we've got those saturated soils in the east where high flows are more likely. And we're seeing our weather strongly driven by the Pacific and the Indian Ocean, with potential for La Nina and a negative Indian Ocean dipole. And the effects this has on extreme weather, we've summarised in the table on the next slide for you. We've tried to do, it's hard to do across the whole of the country. There's a lot of nuance here, but this is probably a good place to to end here. If you want more information, we've got a whole bunch of links that we've put through the presentation, and also collected the most relevant ones here, so you can get all the information we've presented today and more. We have so much information on our website, so when you have a quiet moment, do click on some of the links and have a bit of an investigation and drill down to what you can get for your location. We're on social media, so we like to engage with you on social media. We have a hashtag that you can use to talk about our webinar today. And as mentioned earlier, if we didn't get to all the questions, which I'm sorry because we never do, we get so many submitted. We even had someone else on call to answer some in the chat today. Please submit them to this email address, and if you do, Greg and I will get on to getting an answer for you if your question was missed today.
Great, thank you guys. Our next BOM webinar will focus on the next season. So even though it's a while away, you can never start too early. Summer 2020 Climate and Water Update will be on the 3rd of December. The change of season webinars are our most popular, and we put a lot of effort into them, as you would have seen today, so you can make the right decisions for the months ahead. If you'd like to come along, then please click the registration link that is in the chat now so you can join us. And that brings us to the end of today's webinar. For questions we didn't get to, please email helpdesk.climate@bom.gov.au. A big thank you to Robin and Greg for your time in developing the content and sharing your knowledge with us. And to you, thanks for tuning in and joining us today. We hope you've enjoyed the session, and we do hope you'll join us again next time. If you'd like to continue the conversation with us or with other people, please use the hashtag BOMWebinars in your LinkedIn posts. As mentioned earlier, this session has been recorded, and we will have the video for your on-demand viewing pleasure in the next couple of days, so watch this space. It will be emailed to you along with the presentation materials. Finally, but most importantly, we'd like your feedback. It is our aim to bring you the highest possible quality webinar, but we can't do that unless you share your experiences with us. So once we close this webinar, a short survey will pop up on your screen, and we'd be grateful if you could complete that anonymously for us. Once again, thank you for your time, and we look forward to seeing you again soon. Goodbye.